All right, most of you might have already been on my teacher website before, so this might be some easy navigation for you. But for those that have not been to my website, basically go to the grade level that you pertain to, grade 11, 12, grade 10. On your phone, you're gonna have to move it sideways. If you keep it frontwards or upwards, you won't be able to see these drop boxes. Okay, so make sure that your phone is sideways so that you can see it. But if you're accessing it from the computer, navigate through to your website. So for example, to my grade 10s, okay, you should have your notes, so lesson 1 with the homework attached to that pertaining day. Okay, but on top of that, okay, we have here is a submission box. Okay, so write in your name, your last name, your email that you use, whichever one you use, and basically that should be sent directly via to my mail. The last thing here is upload file. So if you cannot send it via just typing or a computer, it's just math homework that you'd rather show me, take a picture of it. Simply just take a picture of it, and I will receive it, I promise that. Okay, and I'll send you an email just as a receipt, as confirmation, or just message me and just ask me as well, and I can double check that as well. Okay, so that should be relatively easy to navigate through. All right, have a good day. Hello, grade 10 essential math class. Haven't seen you guys in a long time, definitely miss you. Obviously we're gonna continue on with our work. We're actually gonna move away from volume and surface area. We were supposed to go into scales, but we're gonna skip over that just because it's very difficult to teach online. I'm gonna have to figure out some time to figure that out. So we're moving on to what's called identifying angles. Ooh, you would have learned this from Miss Andrew in grade 8, I believe, or grade 7. So a lot of this will probably be review material for you, but for my YouTube, I will be videoing basically everything through my whiteboard here. Okay, so my trusty whiteboard here. I'm gonna talk and explain certain things. So I'll break it down by lesson 1, lesson 2, and so forth. You'll have time to do enough homework, and then I'll give you a little bit of time during the day of each day. Ask me questions either through Instagram Live or just email me. So that's kind of how it's gonna go, I guess. All right, so the first part we're going to talk about is what is exactly an angle here. So we have two parts. One, rotating counterclockwise. So as you can see here, we should see that the angle, right, is counterclockwise going, right? The arm is going backwards almost on a clock, okay? But the terms are still the same, they don't change. So we have two terms here that you guys have to remember. One is the initial arm, okay, which is at the base here. So we have our initial arm here, and we also have our where the angle meets, or where the line meets in this case. We also have our terminal arm, okay. In this example, okay, we have the angle going clockwise, okay. So when we do get to protractors, you need to know the difference between going counter and clockwise, okay. But the terms are still the same. Just keep in mind, right, angle is determined or defined as a shape formed by two lines coming from a common point, called in this case the vertex. So the vertex would be, didn't write it down here, but basically it's this point right here and right here. Those would be called our vertex. Okay. So each line is called an arm of an angle. One of the arms is the initial arm, as we mentioned. The other is the terminal arm. Okay, so terminal arm. The name depends on which direction the angle is opening. There is no indication of whether the angle opens in or clockwise or counterclockwise direction. No distinction between the two names can be made. Okay, but in this example, counterclockwise, moving this way, clockwise, moving that way. Next part of this video is labeling angles here, right? So we'll start, and in your notes you should be able to see all these examples, by the way, so you can always look back and take a look. I'm just here to explain a little bit more just to help you out here. So the first part, right, we have an angle here. We have our point, okay, in this case, our vertex at E. Okay, we'd label this normally angle DEF, but you can also label it F, E, and D. Okay, they don't actually, it doesn't make a difference either way, okay, because the angle is still E in this case. So keep that in mind when you're labeling your angles with the questions that we have, okay. Sometimes angles are named using only the vertex, okay, so, and in this example, you would name the angle as angle E, like I mentioned before. Symbol for that would be, in this case, I didn't put it on here. I'm gonna put that on here now. So we have angle, D, E, F, because in the middle, as I mentioned before, that's actually where our angle is going to be, is E, as you can see here as well, okay? Or angle FED, FED could be the same thing, okay? An angle, in this case, can also have two measures, okay? To understand why, you need to know that one complete revolution of a circle is 360 degrees. So from 0, 1, 2, 3, 4, going right back to its revolution would be 360 degrees in this case. So we know that 90-degree angle, 90, 180, 270, back to 360. But you might start there at 0, okay? So that's what it kind of gives you here, okay? And then in the diagram here as well, okay, they give you kind of an angle, then identified as 45-degree angle here, okay? So our angle, or okay, if we were to label this, we can label this in two ways. We can label it as angle CBA or angle ABC. It does not change the angle because our angle in this case, B is the commonality here. Okay. All right, so the last part to this, talked about the 45-degree angle. We're bringing that back as well. Okay, so inside here, this part here is 45 degrees here. Okay, but what if we wanted to find out the rest? Okay, the rest would simply be everything around in this case. Well, how would we know that, Mr. A? Very simple stuff. Okay, all we really have, what we know for sure is a whole circle represents 360 degrees. Okay, so we have our 360 degrees here. Okay, and we want to subtract it by what we know. Okay, in this case, the angle of 45 degrees. Okay, what should be left over in this case, 315 degrees is where I got that number from, right? So again, I'll just repeat that and make it a little bit more clear here. We have a 45-degree angle and we know that, okay, from inside the angle. So that's, if you can see, that's kind of part of the circle. That curve there is part of the circle there. Okay, but we're missing the rest of the pieces here. Okay, well, if we want to find out the rest or the whole of a circle, we know that the whole is 360. We have a 45-degree angle here. What should be left over? Well, we need to subtract in this case. So we have a 360-degree angle circle, subtract the 45 angle degree that we have here, okay, and we're left with 315 degrees. So that's telling me that the distance from this part all the way around to this part that's not inside the angle, okay, is 315 degrees. What we're going to talk about is the types of angles that we're going to be dealing with. Okay, well, we're going to focus on 5 different types of angles. A lot of these are going to be familiar, might be 1 or 2 that you might not know or remember. So let's kind of memorize this and let's put this into memory. Our first one is our acute angle, right? It's acute for a reason. This angle is between 0 and 90 degrees. So keep that in mind. Anything in between those would be considered an acute angle. All right, next one is the right angle. Okay, most right angles, you'll see a little box here. Okay, that represents the 90-degree angle. That is exactly 90 degrees. Okay, so usually a right angle is shown, like I said, with a small rectangle. When you're doing questions, you might have seen that already. Okay. Next part, obtuse. Okay, the light's a little bit flashing here, but you should see again your arm, okay, and then your terminal arm there. That it should be greater than 90, okay, but less than 180 degrees. In this case, obtuse. Next part is a straight angle. So a straight line represents 180 degrees. That's a rule of thumb, something you should know. Okay, if I were to put a circle in there, that would be considered an angle. 180 degrees there. Okay, and then the last one, which might be new, is a reflex angle. Okay, that's between 180 degrees and 360. So typically you have your little angle here, okay, whatever it may be, but we're looking for to be more specific. We're looking for this. Okay, so this part here is the actual reflex, not what's inside. So keep that in mind. This is what we're looking for. And so those would be your type of angles.
You can use a protractor to measure angles. This full circle protractor is 360 degrees. A standard protractor is half a circle. There are two sets of numbers. The red counts one direction and the blue counts the other. So it is 180 degrees. There are 90 degrees in a square corner and 45 degrees in half a square corner. Let's take a look at this angle. We can use a protractor to measure this angle. First, put the vertex on the center. We're trying to find out how many degrees fall between the two arms of the angle, which we do by finding the difference. We can find the correct measurement of the angle as long as we use the numbers of the same color. One arm of the angle points at the 0 on the right, which is blue, so we can look at the blue numbers starting at 0. The other arm of the angle points at the blue 40. To find how many degrees are between the arms, let's find the difference. 40 minus 0 is equal to 40. This angle is 40 degrees. 40 degrees makes sense since this angle is acute, or less than 90 degrees. The other number this arm is pointing to is 140. 140 degrees would not make sense since this angle is acute. Let's look at another angle. One arm of the angle points at the 0 on the left, so we can look at the red numbers starting at 0. The other arm of the angle points at 120. To find how many degrees are between the arms, let's find the difference. 120 minus 0 is equal to 120. This angle is 120 degrees. 120 degrees makes sense since this angle is obtuse, or greater than 90 degrees. The other number this arm is pointing to is 60 degrees. 60 degrees would not make sense since this angle is obtuse. Sometimes neither arm points to 0. For example, look at this angle. Both numbers we look at need to be the same color. Let's look at the blue set. One arrow points to 50 degrees and the other points at 130. Because neither arm of the angle points to 0, we can do 130 minus 50, which is equal to 80. It is 80 degrees from one end of the angle to the other. We can use the red numbers to see if we get the same measurement. One arm points to 130 and the other points to 50. We can subtract to find the difference. 130 minus 50 is equal to 80. It is still 80 degrees from one end of the angle to the other. We can find the correct measurement of the angle as long as we use the numbers of the same color. In this lesson, you learned to measure angles using a protractor. Thanks for watching.
All right, so the next part is dealing with protractors. I'm actually going to suggest you watch the video that will be coming up next after I'm done talking here. On top of looking at your steps. Okay, so in the notes that I give you as well, it gives you steps on how to draw a proper angle using a protractor. It's really imperative, guys, that you do have a geometry set lying around somewhere. We will be using that quite a bit with some of the notes coming on how to use them exactly. So if you do not have one, let me know. I can pick them up from the school the next couple of days, but you have to let me know. Okay, I'm assuming that when I'm making these videos that you're following along as well. If you don't have something, it's going to be hard to do the homework. Okay, which brings me to my next one, is the homework. Okay, so on the homework, it should be on my teacher website. What I'm also going to put on there is a submission box. So once you're done the homework, whether you want to send it online, whether you just want to take a picture of it, whatever you do, however you send it my way. And as I said before, I'll be readily available. I believe, I have to check the time again, but I believe I have you for 11 to 11:30 on IG Live most days. So if you want to chat with, if you want to ask me questions, chat, do so there. If not, just send me emails, ask me questions. But don't make me chase you around. Okay. Take care. Essential 10. Have a good one.